And so let's go into open discussion now. So basically what I'll do is anyone who wants to unmute themselves, and I guess we'll just try not to talk over each other too much, but you know, anyone who has anything to share, or it looks like Mr. Kenneth Griggs is still with us. If anyone has questions or, you know, anything along those lines.
Yes, I have a question for Ken Griggs. And my question is on your slide, number 45, you were talking about the commutator differential. I'm interested about the orthogonal symmetry. Can you explain a little bit more about it? Your slide is on number page 45 when you were giving the lecture.
Sorry about that. Can you hear me now?
The commutator differential on the orthogonal part. Can you?
Yep, let me get to that.
Number 45.
Give me 1 second.
You have A, the symmetry, and C, that would be the orthogonal.
Okay. Almost there. Okay, come on. There we go. Okay. 45, and okay, so tell me one more time. What's your question? Sorry. Oh, there we go. Okay, yeah. Okay. So the orthogonal matrix that we're talking about here is the matrix that we're normally associating with the transformation matrix. It's what takes you from one of our graphs and how that matrix actually transforms into a new graph or into a new matrix. And so the general two types of matrices that are used in Kaufman's differential calculus fall under those two rubrics. One being a symmetric matrix, which in Phoenix is a matrix describing space, and the other being an orthogonal matrix, which is a matrix describing time or evolution. Did I answer your question, or?
You spoke earlier about the representation of time being its own independent.
That's right.
From
That's
the
right.
other. Normally, Einsteinian 4-dimension, Kaluza 5-dimension. The reason I'm interested on that one to know, where can I find more information about your theory, the mathematical theory, because I need to read in more detail.
Okay, so the best source right now is Louis Kaufman's papers, and I've actually referenced them in this paper. Let me find one of the references.
You can put it there on the chat. So the reason is because I have a machine and I'm producing, you know, a three-dimensional, you know, the way to represent it, you know, the thrust effect I'm producing. I found out that 5 axis, you know, 5-dimensional, like Kaluza, fits like a glove.
Okay.
I have the 2 axes are producing orthogonal Lorentz forces, and the other one axis I'm producing a magnetically induced gyroscopic force. I can whether the machine, the rotor is in the vertical or the horizontal position or in between, and then I have the orthogonal effect would be an axis that is reactionary. Well, I represent the reactionary axis, which is orthogonal to all 4 axes, time and the XYZ dimension. And so I've been working on that problem represented in mathematical space. And you mentioned about how the time may be independent. So I'm interested in exploring that more because I want to make I want to publish very soon, and I want to make sure I have an accurate representation with the data and everything I need to do. But it seems to be like that, fits like a glove. And when you mentioned the orthogonal and the symmetry, yeah, I need to look more into it. So, because I think that will work into my research on what I'm doing, that I can take my data and show it. And
fantastic.
The mathematical structure that will fit it, will describe it well. Could you be able to send me a copy of your theory where I can find it, you know, the lecture that you gave today and more information on detail?
Yeah, I'd be able to do that.
I will send you my email.
Okay, that's great. Thank you.
Okay, so that you can.
So Ken, can you see that on your screen?
I think I have it.
Yeah. In minutes, 2004. It's not moving. This is just an image of the background.
Yeah, okay. Michael, can you talk up a little more?
Okay, sorry.
Sorry about that.
How's that? Better? So basically what we have here is the Tic Tac.
Yes.
And this is the infrared imager. And I worked for 10 years for Hughes making images. And so what you see here is above the Tic Tac, there's a dark region. It's like a balloon. See that there?
Yes.
And if you look at it, it's rotating counterclockwise. You watch closely. Okay, and then over here on the right, there's this like bright region, another little like balloon bright region. And then over below it, there's another region, which is like, looks like it's going both ways.
Yep.
And then right next to it, there's another little region. And this looks like it's spinning, but part dark. And what the color differential is the white area where the Tic Tac is in the center, that's hot. The dark areas are colder.
Very cool, right.
Okay, so these are thermal effects, but they're due to the engineering of the space-time there by the Tic Tac. Now over here on the left, see this like undulating area here?
Yes.
Okay, that's where your wormhole is.
Huh.
Okay, now watch. I'm going to go to this. These frames are included with the. Hold on a second. Got to shrink my screen down here. So I can pick the right. Oh, there it is. Okay.
Yeah. Okay.
Oh, got the wrong one again. There we go. See this one now? So now what it looks like is going on here is, think of it like a bow and arrow. Okay, you pull the string of the bow.
Right.
That's on the right side here. And when it releases, that's your ward. And the Tic Tac is the arrow.
Exactly.
And now notice how the Tic Tac, right before it disappears, is like all stretched out. Now, how Puthoff's hypothesis is that the region on the left is expanded space-time.
Yes.
Where basically time is faster there. So, I mean, you can go superluminal in expanded space-time. But it's not superluminal to the person in experience.
That's right.
Okay, so they're not experiencing any of the G-forces.
Any of the G-forces or the time dilation or
just the observer. Now on the right region, where that's the denser space-time, and that's basically like if you get closer to a star, basically time slows.
That's right.
Near a black hole's event horizon, time basically stops. So now that's this is basically quantum gravity in application.
Yes.
Correct?
Yeah, I mean, it's what we would expect if we were looking at a gravity wave for which we have, part of the gravity wave, which is compressing space, and the, maybe the forward part or the aft part of the gravity wave, which is relaxing space. But yeah.
So basically, what I discovered. Let's see if I can. Okay, so can you see this signal I have here? Okay.
Can you hear me?
Yeah, I can hear you. Can you hear me okay?
I got cut off there for a second.
Okay, so what I have is what I used to work in the heart. This is a signal. This is a nanogravity signal from a pump on a spinning disc, and what I'm measuring it with is a thing called a GMR sensor. It's a giant magnetoresistor. It's the part of the reed head on the heart. And essentially, what happens is when the pump goes under it, the edge of the pump creates a magnetic induction signal. And that's what this first signal is here. It's as the rising edge of the pump goes up, it produces, and that's at the speed of light. And then as the other edge goes under the sensor, the magnetic sensor, it produces this other pulse, the opposite polarity. The gravitational induction signal is in the middle here. See this broad signal? See how it has the surface noise. That's called the noise signal. So basically, this is an example. And now for a nano pit, I got just the opposite. These little signals are there, but it goes the opposite direction. But essentially, and then what's going on here is as the bump, because the bump is closer to the sensor, the space-time, it treats it as denser space-time. And that's why there's a post signal, because the actual signal, the actual gravitational signal is it starts later than the edge. So it's time delayed. Now, I don't have a pit signal right here, but it does the opposite. It goes up like this, but then there's a pre-signal. So when you go into the future, right, so basically moving matter can, a little bit of it goes into the future. Now the other interesting thing I would like to share is when we're talking about quantum tunneling, I'm going to go off the share. Stuck in the chair.
Okay.
Sorry about that. Stop.
There you go.
Sorry, I'm technically failed. So the other thing I was about, you're talking about quantum entanglement, correct? And so when I worked for Hughes back in the 80s and 90s, we worked on these things called tunnel guiders.
Okay.
And that uses a kind of uses quantum tunnel. And so basically, what happens there is it's like a barrier problem. And the interesting thing about quantum tunneling is the data that's on the opposite side of the barrier is advanced in time. It goes into the future. So it's not actually simultaneous. It's not actually instantaneous. It's actually post-quantum. Okay. And a lot of folks, when they think of entanglement, they think of it as simultaneous. And this also, I think, applies to your conscience.
Yes.
And how we think. And basically, that's how we actually read the future a little bit every time we have a thought.
Yeah, that's, I think one set of researchers were talking about microtubules and the idea that
Penrose.
Right. Exactly, Penrose, exactly. And his other researcher out in at Oxford, I think. But yeah, the idea that that these microtubules are creating these entanglements that enable us to really, for the most part, have little short steps forward and backward in time, such that we're just almost bypassing some level of time to achieve the notion of consciousness, yes.
Well, so the point, my interest in it is that it means that it could suggest that consciousness doesn't end well. That something, basically it's something embedded in the internet. It's kind of like, Bohm's pilot wave theory. The speaker before, I was going to ask him about that. He thought what he was talking about this.
Right.
You think that's what we're talking about with these like generation functions, essentially?
Well, I certainly think that I'm not certain as much, only because I'd have to investigate it a lot more. But I certainly know that in terms of what generating functions enable us to speak about are all types of measurements, even if those measurements are, flipping through space or as it were, conjoining two moments in time or conjoining two moments in space together. There are still measurable phenomena. We talk about entanglement, but yeah, the idea is that entanglement happens both in space and time. And we have to be able to, and we do in physics already, but to weed out which ones we're really dealing with in those discussions.
That we can actually, with electrons, we can change the temporal relationship between them. That we can make a entanglement state where the two electrons, one of the electrons doesn't entangle to a future time.
Right.
They don't have to be the same.
That's right.
And
the beauty about some of the work that we've done is to directly ask the question about whether or not, how is it possible that the future dialogues with the past, right? And, definitely the way that we've been assigned to think about physics is that physics is causal. So there's a past, there's a future, and we're only moving into a future, never having the ability to go backwards, blah, blah, blah. And the reality, and I don't agree with that by any stretch. I think that
in the black hole, if I point you to the black hole, you could perceive that nothing's changed.
That's right.
Right?
All right.
You don't know which way you're going.
That's right. You really don't.
You could be going to the past.
Okay, know, I'm moving into the past, and there's nothing I can do about it now.
That's the beauty of it.
That's right. But and
just a relationship, right?
It's true. And the thing about having negative energy states, for example, is that at least in terms of the field theoretic equations that we use, which are basically any equations that deal with space and time as actual entities, but those field theoretic equations that we use demonstrate to us that negative energy will begin to unfold our whole notion of causality. And so, you know, when Alcubierre was envisioning using negative energy in order to accomplish, you know, the folding of space such that it could produce a warp, you know, a warp acceleration or a warp field. You know, the reasons why physicists came back at him, it was simply because this way of doing it seems to violate causality, and not certainly respecting the idea that Einstein's GR definitely violates causality. But what they were saying is that if we exclude negative energy states, we got causality back, and everyone should be happy. Which then, of course,
well, I think the problem with Einstein was he got this award for discovering the photoelectric effect. And basically,
Brownian motion,
and you know, electrons and photons. And I'd say he was blinded by the light of electrons, and he missed the holes all around, because that's where the energy is in all those holes, or protons.
Yeah. I mean, in so many ways, you know, Einstein's fight, obviously, with quantum mechanics obviously it seems to have been disruptive, but of course it wasn't, because he's the one who gave us entanglement. You know, if he hadn't cracked into quantum mechanics as deeply as he did, you know, we would all not have any notion of entanglement in a relevant way today. So, you know, I dismiss Einstein in other ways, but in that way he did help us.
Well, I believe Einstein, not because he's Einstein, but because I think that his life is different.
Yeah. This is, you know, for me, it's never about, you know, any notion of hero worship.
But that goes back to me thinking God's a she. So.
Yes, exactly. You know, the whole notion of Maleva, right? You know, when I try to describe the 1905 Untergang, you know, a year for Einstein, the main thing that comes to mind is that he was deeply in love with Maleva.
Hold that thought, Ken. Hold that thought, Bernie. That picture there of the chief in the is that in Utah by any chance?
Yeah.
You know how I know?
How?
Because I studied geoglyphs. I got a paper on the called Puna de Atzan. It's archaeology. And when I was doing Google, I was looking for other features that you could see from where we were, and I came across that. I said, oh, yes, I think I still got a copy of it somewhere. That's a pretty cool feature, don't you think?
It is awesome.
So if you ever get a chance, check out Kokopili. You know who Kokopili is? Kokopili.
Okay.
The guy with he's playing a flute. He's got like the wild hair, dude. That's because he's got the head of a bee in the body of a bee. And he's here for light telephone. So if you Google Kokopili geoglyph, you can see him from space.
Wow.
And then right next to him is Lutz.
Sorry, sorry to interject. Someone called Bern Crone, I think, sharing the screen. I think they may inadvertently have shared it, because we've just seen them use Paint 3D in Windows 10.
There, yeah, sorry. I'm meaning to share it, actually.
Yeah, that's pretty cool, Bernie. I like that.
So I'm trying to create here a geometric dimensional vector or force vector unified field of everything. It has to do with the octave scale, Walter Russell's work, the platonic solids, color, sound,
The
resonance.
universe isn't platonic.
Sorry?
You don't live in a platonic world.
Well,
it's not flat.
Well, that's your one-dimensional disk, right? And then you have your two-dimensional, like your polarized rod that from light, electric 1D field on a disk, 2D polarized rod of opposing magnetism.
Oh, it's got
your three-dimensional sphere. It also includes gravity. That's like your three vector at that point that encloses your volume for the first time, which then creates that 3D sphere. And then your 4D is that sphere connecting to the higher dimension through one more D of time space, essentially your quantum or your
tetrahedron on the left there.
And then after your 4, it goes to 5 being and 6, 7, 8 with the higher dimensional platonic solids, but it's like trying to comprehend that high of dimensional theory, right?
Yeah, that's cool. Well, you know, the strongest material is a tetrahedron. That's what
So the way I look at the one dimension is like it's a disk, it's like your record. It's a record, it's a page in a book. It's recording all information in that moment of time.
So it's got a stylus. You know what I mean by a stylus? Like a you know, the old diamond stylus on the really good record player had a diamond stylus.
Right, but so like it's a moment of time from the perception of the consciousness or all of the consciousnesses.
That's cool.
And it's recording all information within that localized moment of space-time. And then as you're flipping through the greater space-time through like the solar system moving within the galaxy and whatnot, it's like an 8mm film, or like you're flipping through the pages of a book, and the consciousness is the cartoon that is created in the motion of those flipping between, right?
So, hey, Bernie, you got that on a website, or is that just like a presentation?
This is just what I've been working on it. It's in many of my journals for I've been writing on and working on for 10 years, but I haven't published it or put it onto any internet sites or anything.
No, I like the whole concept. I think you're totally on something.
Thanks, brother. I appreciate that. And it's like, so I did this during a live stream marathon the other day, just through paint, putting together as many of these references as I can, and then as well as a little bit of my own artwork and stuff. But I got some actual graphic digital design artists that I work with that will actually turn this into something much more coherent and unified in the coming future.
Cool.
Lastly, I just want to point out that the Indian heads there, the one picture in the center right, that is a road going up to an oil derrick, and so it's essentially like on the scale of the Nazca lines and stuff like that.
Right.
And this is actually in Medicine Hat, Alberta, Canada, only a couple hundred kilometers or less than 150 kilometers away from where I live. And yeah, it's like that right there redefines world history, because who made that in Canada and when? But there's all sorts of hidden mystery.
That's interesting. Why? Is it on public land or is it on private land?
Sorry?
Is it on public land or private land?
It's in public, in the Badlands there. in the, and so
we got a permit to drill there.
We'll have to check out the Farnham Research or Farnham Foundation. He's the discoverer of it, and he actually found a system he calls geoglyphs that are megalithic structures within these different sites that plot out and map and connect to every other ancient megalithic site across the world. And it's too much for me to try to describe right now, but it's just mind-blowing and revolutionary. It's crazy. Like, it links like the Bosnian pyramids, the Egyptian pyramids, Yanaguni Islands. All of them are mapped out in this Alberta Canadian room. So
it's on a ley line.
Yeah, oh yeah, it's a major ley line.
Can I ask a question now, please? Can I to Ken, please?
Sorry, 1 sec. Okay, sorry about that. Yes.
Thanks. Great contribution.
Still here? I don't know if he's still here.
What can I do for you, good sir?
You still got your screen on share, yeah?
Yeah.
That's not me. That's Bernie's got the screen on.
Yeah.
But I don't see Ken here anymore.
Yeah, he's gone, I think.
Yeah, we're down to 14.
Yeah, who are you looking to ask?
I want to have a word with Ken. I want to have a discussion which might be of general applicability to everybody. Yeah, I just wanted to ask him a question. It's all right. You unshared your screen.
Yeah, for sure. Sorry about that.
Yeah, thanks a lot.
Stop. There we go. Sorry about that.
Okay. I think he's gone. He's gone.
Yeah, looks like it's you, me, Sam.
Yeah. It's 2 o'clock. 2 o'clock in in the UK, so I might be logging off too. Yeah, 2 o'clock now.
I had fun.
Michael, did Mike from Toronto with Faraday Research ever show up today?
I don't know.
Okay, probably not then. Do you mind if I share a video I did the interview with this electrical engineer the other night? He created his own end machine, his own pulse motor, as well as he's now doing a Don Smith generator.
Sure. That's information.
Just about. Is it playing the sound or no?
I can hear you.
But you can't hear the...
If you have the volume turned up.
Mike, is it all right instead if I post the link in the chat and you play it instead?
I can try that if you want.
I muted myself there just to see if it was me that was causing that feedback there, but I guess it wasn't.
It's like 2.5 hours. All right. Can you hear that okay? All right. Okay, let me go to share. My penalty from autodidactic I have with me. Bernie, the burn-eye, mind's eye, science guy without bow tie, and Mike from Parallel Research. And we're going to have a bit of a chat today about all things. What's that? Can you guys see that okay?
Yeah, absolutely.
Basically been doing a lot of experiments on free energy, so we're going to touch on that, and then get a bit of a grounding into what electricity really is. Of course, I don't like to know all this stuff. So, welcome, guys. Hello, everyone in the chat, and welcome, Mike and Bernie. Hello, hello. You have the full Bernie. That brings up. Oh, okay. Hello to all you beautiful souls in YouTube land. Tonight is our part 2 with Mike from Heritage Research.
Maybe put it to like 5 minutes in or something.
First time that we are streaming multiple YouTube channels simultaneously being autodidactic. We have a problem that not only it won't count, you also have a problem with medicine. I'm going to put the link. So, he is trying to confirm what I just talked about. And it's working. So, what do you feel about it? I've been talking about opening up the power. Okay. So that is the generator. The motor in the generator is air goes to high voltage. And then the high voltage transformer goes to the right? When he's got it set up in this configuration, this motor here is wound down so heavy that it starts drawing enough energy. Okay? That's a lot of stress on the motor. Then you have a problem that generator. Not only is it broken down, you also have a problem with ventilation. You have a problem. Hey, Bernie, this is kind of boring. Where's the good stuff?
Sorry, gotta skip ahead there. There's a part there where we go over Jared Morin's work, and that's it.
Okay. So that you see down in the left here, you can see the screen capture.
Yeah, probably about 45 minutes in or so on it.
Okay.
Oh, we go over Eric Dollard's induction. Eric Dollard's induction generator. Maybe.
What's that, about 40 here?
That's about 20 minutes.
20 minutes.
Yeah, right there.
Okay. Is that Edison?
I believe so. Right at the end of this presentation, or like this little video would be the part to bring up, because then Mike really goes in depth in explaining the induction and stuff. Although if you haven't seen Eric Dollard's most recent upload,
right here?
Yeah, this is pretty good. This is Eric Dollard's most recent work on their cosmic induction generator.
So I was able to really move forward when a couple of years ago, a lot of people were showing up with equipment. So this is,
have you seen Eric Dollard's work, Mike?
What's that?
You're familiar with Eric Dollard's work, right? No? Oh my gosh. It's too much to get into right now, so I'd say just like skip to the end of this guy talking when all four of us or three of us come back in, and we'll be able to, that's a good part to come in. That's their cosmic induction generator.
What did you say that was called?
So this is possibly transmutation through different frequencies, changing the ionized gas into different plasma elements through what carbonics they're putting through it.
Is that an RF field or is that just electric?
RF, yeah.
Aren't they worried about getting cooked?
Eric Dahl,
multi-screen.
yeah, he's too much to explain myself. Just play it. Let a couple minutes of the conversation play here, and Mike's electrical engineering knowledge is quite good.
Sponsored by Sir Shark.
There you go. Yeah.
Figuring it out. So I
there you go.
tonight because I figured it's very relevant with your Don Smith generator as well as what you're talking about with the spark gap generator or spark gap.
Yeah, you're using the same method to create that. So if I build off that, I would have to get different parts. So about the two Tesla fluids is really each other. And when you take the neon tube or a fluorescent bulb in between the two Tesla fluids, there will be area in the middle of that tube that's in the front. That field, the two fields basically collide. They counter space like a void. So that is kind of the mystery of how that's, what's actually happening there, because basically a black space in between the fields.
So it's like an energy vacuum almost.
Almost like a black hole.
Almost the center of the voting coil. And like Ken Wheeler's carousel there was like the center of the magnetic field. It's also black hole. Yeah, the toroid, like Daniel Newman and the one-stop energy, their resonance coils, like their more advanced rodent coils. And they as well, when they have vortex, like the same black hole in the middle of the interaction of the center of it.
So it's similar to like, just a regular motor coil. So when you get the back EMF and it collapses, it can only collapse in on itself so far in the center. And that's when it's called a blotched wall. All right? And when it hits the blotched wall, it can't go any further. So what happens is it's actually the opposite direction.
You have an audio cord, auxiliary audio cord plugged in at all? Or does anybody have an auxiliary audio cord that are you guys having that horrible like static as well in the sound? Here. Maybe it's just mine that's.
So this is more what you think the voice.
So is it a balance effect? Do you think someone's going into it, but someone also comes
What are we watching here?
Like, is there that horrible for everybody? Like,
Okay.
I can't hear you. All I can hear is like.
Yeah, I got it.
Did the evil alien sounds end for everybody else now? Like, Mark, were you hearing that crazy, like?
Yeah, what was that?
I have no idea. It seemed to be coming from Michael's end, though, I guess. That was weird.
Is anyone else still on?
We have Harold here. Harold, you're with us. Is Tim still here? I was showing, Mark, do you know if my buddy Mike from Faraday Research, did he show up in the Zoom at all today or no? I sent him the link. He's very, very, he's a career electrical engineer. He works in the, I think, aerospace industry in Toronto. He does his own 3D printing, but he built his own end machine. He built his own pulse motor, as well as he's now working on a Don Smith over Unity generator. But that's what I was getting Mike to show. There was a little bit of the interview, but for some reason his stream, his stream was glitching right out. Do you mind if I try doing a little bit more of it?
No, not interested.